Welcome to day 5. We've got a warm-up today, so on your warm-up sheet for Wednesday, I want you to try and do this without looking at your new study card. You want to tell what each of these implies, so go ahead and pause the video now so you can do each of these 3, and then when you hit play, it'll ask you for your responses. When you put your responses in, if there's any symbols we normally write, you'll have to write out what they are in words, because there's not necessarily the symbols that you can put in. So again, you'll have to put your responses all in words, like how we would read it. All right, so congruent triangles. Once we have triangles congruent, we can do congruent triangles implies congruent corresponding parts. We've got parallel lines could give us one of 2 things. It can give us congruent alternate interior angles, or it can give you congruent corresponding angles. Well, then 3 is just the reverse of those. Congruent corresponding angles implies parallel lines. And congruent alternate interior angles, remember alternate interior, we get to the angles that zigzag, also implies parallel lines. All right, moving over to the homework. We're given that AB and CD bisect each other. So we're bisecting, we've got segments, so we want to use segment bisector implies midpoint. Because they bisect each other, E will be the midpoint of both. So E is the midpoint of AB and CD. Automatically, we should know in step 3 then to do midpoint implies 2 congruent segments. So we'll have 2 sets of congruent segments because E is the midpoint of both of them. So we get 2 sides from this here. We've used this given as far as we can go. So look for your vertical angles are reflexive. We have crisscrossing lines there. We can do vertical angles. Label them 1 and 2. You got your vertical angles implies congruent angles, and angle 1 is congruent to angle 2. So now we have an angle. Looking at our picture, we have an angle between 2 sides. So that allows us to do side angle side, congruent to side angle side. Now, in your statement in 5, when the triangles are congruent, remember, name the first triangle anything. So I named it CEA. Well, C was between the 2 mark side and the no mark side, so that had to match with D. E was my vertical angle, so that matched with E. And then my A was between the 1 mark and the no mark, so that had to match with B. So you need to be able to identify what goes with what. In this particular question, they told you in part A, but again, you will have to be able to match those up. Well, if we want parallel, we just saw from the warm-up, we get parallel when we have congruent alternate interior angles or congruent corresponding angles. We've got a zigzag here with our parallel lines. I did my zigzag going that way. You could have done it going the other way and used C and D as your angles. So everyone in reason 6 should have congruent triangles implies congruent corresponding parts, but in statement 6, you can either have what I have, A congruent to angle B, or you could have done angle C congruent to angle D. Either of those would have been fine. And then everyone should have the same last step. Congruent alternate interior angles implies parallel lines, and you got what we wanted to prove. All right, in this one, we were given A, B, and C, D congruent. We had angle 1 and angle 2. Well, that gave us a side and an angle in our triangles. We can do a reflexive property easily to get another side. So we've got side, angle, side. We wanted parallel lines again. We wanted BC and DA. So trace your BC and DA and do your zigzag. The angles of the zigzag are the ones that I labeled there, 3 and 4. So you'd either have to number them like that or use 3 letters. We get those congruent in step 5 by congruent triangles implies congruent corresponding parts. And then we can use the fact that we now have congruent alternate interior angles to imply the parallel lines. Okay, we needed those ones labeled 3 and 4 because they are the angles of our zigzag for the parallel lines we wanted. You could have used angles 1 and 2 if they wanted CD parallel to AB. Those would have been the angles of the zigzag for those ones, but we needed the ones labeled 3 and 4. So we have a straight line or a straight ray ACD. CA is congruent to CB, so we had these. And we had angle ECB congruent to CAB. We can do two congruent sides implies isosceles triangle. So that gives triangle ACB as isosceles. Then isosceles triangle gives us two congruent base angles. So that gives us this angle CAB congruent to what I called angle 1. Well, notice CAB got marked up twice. So that means there's two things congruent to it. So we can do transitive property to get ECB congruent to angle 1. So this angle here now is congruent to that angle there. Well, based on that zigzag, those are congruent angles in our zigzag. So those are congruent alternate interior angles. That implies parallel lines and gets us what we wanted to prove. Next one, we're given BA congruent to BC and angle BDE congruent to angle BCA. So those big sides allow us to say that the big triangle is isosceles. So triangle ABC is isosceles. And because it's isosceles, we can say isosceles triangle implies two congruent base angles to get those two congruent. Well, just like in the last one, notice that one angle gets marked twice. So do a transitive property, and that'll get BDE congruent to angle A. So we now have these two congruent to each other. Well, notice if we extend our lines, those are both in the top right. So those are corresponding angles. So we now have congruent corresponding angles, which implies parallel lines. So that allows us to get DE parallel to AC. If you want to prove something's parallel, you want to do whatever you can to get either congruent corresponding angles or congruent alternate interior angles. All right, we will start on page 22 today. We're going to look at a little bit more challenging corresponding parts of congruent triangles problems. So when do you use corresponding parts of congruent triangles? You cannot use it until after the triangles are proved congruent. So that means after you've done side, angle, 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 side, side. After you've done those, that's when you can then use your congruent triangles implies congruent corresponding parts. And that leads us to the second one. What's the actual reason? We've got congruent triangles implies congruent corresponding parts. So once your triangles are congruent, any parts that are in the same spot are also congruent. So we are going to jump around in this video a little bit. We're going to jump to page 23, and we're going to do number 3 to start out. So we'll do our statements and reasons and our givens. Okay, so let's look at our proof statement and come up with a plan. We want to prove AB is congruent to ED. So those are two things congruent that are in different triangles. So the thought that we want to think is, okay, let's get the triangles congruent, and then we'll be able to use our congruent triangles implies congruent corresponding parts. So that's the plan. Do what we need to do to get the triangles congruent, and then use that one extra step. So, kind of like we've been doing for a while with proofs, we see perpendicular lines, so we should automatically know by this point that perpendicular lines implies right angles. We're pointing at right angles, so we got to make a statement about right angles. Well, let's see where those perpendicular lines meet. AB and BD are meeting right there, and ED and DB are meeting right here. So there's only one angle happening at each of those spots, so we can use a single letter. We can say angle B and angle D are right. Well, as soon as we say we got right angles, we should automatically know by this point that we do right angles implies congruent angles. We're pointing at congruent angles, so we've got angle B then congruent to angle D. We've set it in our proof, so let's mark it in our picture. We'll mark it with a box because they're right angles. Angle B congruent to angle D, and those are angles in our triangle, so we'll put a little A there. So we've used our perpendicular lines ones as far as they can go. Let's go to our third given. We've got the word bisects. So that means it's either segment bisector or angle bisector. Look after the word bisects, and we have a segment, so that tells us it must be our segment bisector reason. So we should automatically know by this point that segment bisector implies midpoint. We're pointing at midpoint, so we've got to make a statement about a midpoint. In your statement of midpoint, you got to name the point and say what it's the midpoint of. The one that's getting bisected is always what comes second. So AE and BD cross at C, so we've got C is the midpoint of, and it's always the one that comes after it, so BD. The only time it's both of them is if they say they bisect each other, which this did not say. Well, automatically next, we should know to do midpoint implies two congruent segments. We are pointing at two congruent segments, so we've got to say which two segments are congruent. Well, if C is right in the middle of B and D, that would be BC congruent to DC. We set it in our proof, so let's mark it in our picture. Those are sides in our triangle, so let's put an S next to there. So we've used given 3 as far as we can go with it. But we only have two things. We should know to look in the picture for reflexive property or vertical angles. Those are our big two. Every now and then you sometimes see transitive property as well. But reflexive and vertical are the big two. We've got crisscrossing lines, so we want to use vertical angles. So we'll number those 1 and 2. So hopefully by now we automatically know our vertical angles reason. We've got vertical angles implies congruent angles. So we're pointing at congruent angles. We got to say which angles are congruent. That's the angle 1 congruent to angle 2. We've set it in our proof, so let's mark it in our picture. Those are angles in our triangle, so we'll put a little A next to it. We have 3 things. So we are ready to state they're congruent. We have 2 sides, or 2 angles and 1 side. Notice the side is in between the angles, so that makes it angle, side, angle. So for step 9, we'll have ASA congruent to ASA. Now we got to be careful when we name our triangles. They didn't give us them. So you just name one of the triangles anything you want. So maybe we'll call it triangle ABC. Now for the other triangle, we got to make sure it matches. And this is where your markings really help you. Notice angle A had no markings on its angle. So that's got to match with the angle that has no markings in the other triangle. So E. B was where our right angle was. That should match with what has the right angle in the other one. So D, and then our leftover letter is C. So we'll have triangle ABC congruent to EDC. So you must take the time to make sure they're matched up properly when you name the triangles congruent. Well, great, we're just about there. We've almost executed our plan. To get what we want to prove, AB congruent to ED, we've just got to do our congruent triangle step. So we'll have AB congruent to ED. And that's our congruent triangles. Implies congruent corresponding parts. So that reason is such a powerful reason because it allows us to get anything else in the triangles congruent that we want. It allows us, we saw in the homework last night, to then use, like say, those congruent angles to get parallel lines. So it's really, really powerful reason. So the next one I want to look at is to go ahead to page 24 and look at number 5. Okay, so again, we're going to jump around with these. So let's take a couple minutes, do your statements and reasons, and get your givens down. So let's come up with a plan for our proof. We want to prove that PQ and RQ are congruent. Well, those are things that are in separate triangles. PQ's in this triangle, RQ can be in this triangle or that triangle. But if you look, just kind of observe it, it's probably that triangle that we want to get. So our goal is to get those 2 triangles congruent. And then once we have those 2 triangles congruent, we can do our congruent triangles implies congruent corresponding parts. Well, they already gave us MR congruent to MP. So let's mark that in our picture. That's a side in our triangles that we want. They told us just that the MNP is a triangle, and then we have bisects for given number 3. Look and see what comes after the word bisects. We've got an angle. Okay, that tells us automatically we're doing angle bisector. Implies 2 congruent angles. It can sometimes be difficult to pick out where the 2 congruent angles are, so trace that original angle, PMR. Here's PMR. QM is bisecting it. So those two angles that get split are the ones that we want. Okay, I would recommend doing that anytime you have an angle bisector. So let's number those 1 and 2 to make our life easier. And our statement will just be angle 1 congruent to angle 2. We set it in our proof, so let's mark it in our picture. That gives us another angle in our triangles. Well, we've used all our givens. We don't have enough. We only have 2 things marked, but notice they are sharing MQ. So we'll put a little X on that and we'll do reflexive property. With our statement being that MQ is congruent to MQ. And that now gives us another side in our triangles. We have 2 sets of sides congruent, the angle in between them. So if you have 2 sides and the angle in between, that's side angle side, congruent to side angle side. And we've got to be careful naming our triangles. Name the first one anything you want. So we're going to name it triangle PMQ is congruent to triangle. Now we got to be careful with this second one. P down here was the angle that's in between the 1 mark and the no mark sides. PM had 1 mark on it, PQ had no marks. So we've got to find the angle in the other triangle that's in between the 1 mark and no marks. Well, that would be over here at R. So we got to start with R. Then M is the angle from the angle bisector. So that matches with M in the other one. And then our last letter is Q. So RMQ for the second one. So you got to take the time and be careful naming them so that they match up. And then to finish it off, we just did congruent triangles. So now we can do our congruent triangles. Implies congruent corresponding parts. And our statement is just what we wanted to prove. That PQ is congruent to RQ. All right, we're only going to look at one more proof in this video. We're going to go back to number 2. And we'll give you a few minutes to get down your statements and reasons and your givens. All right, let's come up with a plan. We want KL congruent to TW. Well, those are sides in separate triangles. So our goal should be to get triangle ATW and MKL congruent to one another. And then we can do our congruent triangles implies congruent corresponding parts. Well, they give us ML congruent to AW. So here's ML and here's AW. So we got one set of sides. Angle 1, so we'll put an S there. Angle 1 is congruent to angle 2, so we'll mark that in our picture. That gives us an angle in our triangle, so that's good. We're 2/3 of the way there. And then they give us KT congruent to MA. Well, here's MA, here's KT. Those aren't sides in the triangle. So we can't mark that with an S. So what we need to do, our sides are too short, or they're short of a side. Okay, those segments we have are short of a side, so we need to add some more on there. And both need MT added to them to give you a full side. So because we're going to add the same thing to both, let's do a quick reflexive property. MT is congruent to MT by the reflexive property. And then we're going to do our segment addition postulate sequence. So it's been a little bit since we've done those. Remember, it's a 3-step sequence. In the first statement, we take one of the small parts, so MA, plus the other small part that will make a side, MT, and tell what that's going to be congruent to, the side that we want, AT. Do it for the other one. We've got MT plus TK added together will give us the side that we want, MK. Remember our reasons, go 3, 2, 1. 3 words, 2 words, 1 word. So the first one is segment addition postulate. The second step in our sequence, we take the side of our previous statement that had 2 things and make them congruent to each other. So we've got MA plus MT congruent to MT plus TK. And that, remember the 3, 2, 1 for our number of words in our reasons. This should have 2. This is just the addition postulate. And then the last one is what we are trying to get, the sides that are actually in the triangle. So AT is now congruent to MK. And 3, 2, 1 for our reasons. This is one word. This is substitution. We said they're congruent in our proof, so let's mark it in our picture. We've got AT and MK. So here's MK. And there's AT. So notice we have the blue sides and the purple sides, and then the blue angles in between. So 2 sides with an angle in between, that's going to be side, angle, side. So we'll have SAS congruent to SAS. We'll have our triangles congruent to each other. For the statement, we got to figure out what the names will be. So the first one I'm going to call MKL. Well, M was down at the marked congruent angle, so that should match with A. K was up at the top there, that should match with T, and then W. So MKL is congruent to ATW. And again, name the first triangle whatever you want, and then just match it up in the second triangle. And then to finish this off, we'll do our congruent triangles. Implies congruent corresponding parts. Again, this step should never be done until you've already done your congruent triangles. So you've already done side, angle, side, angle, side, side, or angle, angle, side. And our statement is just what we wanted to prove, that KL is congruent to TW. So that's it for this video. Have a great rest of your Wednesday.